Assalamualaikum warahmatullahi wabarakatuh. My name is Aino Patisha Dalina binti Muhammad Ali. My student ID is 2024249196. My groupmate and I will be presenting the result of an experiment titled linear motion. The objective of this experiment is to investigate the relationship between force, mass, and acceleration. This experiment is also conducted to determine the acceleration of an object under a varying force. Linear motion is a motion of straight line in one dimension. When the object travels or moves in a straight line, it will change the time. Newton's equation of motion that we'll use and apply is F equal to ma, which m is mass and F is force. When m2 is released, both objects will accelerate. The two masses will have acceleration a of the same magnitude. The force from the contact of the frictionless surface pushing up on m2 labeled T. The contact and the gravitational force cancel each other, meaning the total force acting on vertical direction on m2 is equal to 0.
Hi and Assalamualaikum. My name is Nurul Azmi Asmi. My ID is number 2024238578. So, to conduct this experiment, we need to use a treadmill, blower, pressure tube, gliders, flags, photo gates, masses, mesh hanger, string, and pulley.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najmuddin bin Muhammad Rosi and my ID number is 2024237982. And today I would like to share with you guys about the procedure for experiment 4. First thing first, we have to make sure that the line air track was assembled as in the lab manual as shown in figure 4.3. Then make sure that the pump was switched on and the air was allowed to flow through the track. Let it flow for several minutes. Next, make sure that the track was balanced by adjusting the screw on the leg of the track so that the glider remains stationary and did not glide to either end when let go. Once done, make sure that one hook was inserted at one end and a flag was placed on the top of the glider. Please make sure that the mass of the hanger and the mass of the glider were measured and recorded. Then the length of the flag must also be measured. After that, make sure that one end of the string was attached to the hanger and the other end of the glider. Mass of 20 grams must be placed on the hanger and another 80 grams were placed on the glider. The string was then put over the pulley. Next, make sure the glider was positioned exactly before the photo gate. Release the glider and record the time shown on the photo gate. For a secure measure, please make sure to avoid the masses from crashing to the floor and scattering. Cut the glider with the hand before the hanger reaches the floor. This step was repeated 2 more times to obtain the time average value. The sorted mass on the glider was decreased by transferring a mass of 20 grams onto the hanger. And the last step is repeat the step 7 and 8 3 more times with 20 grams from the sort mass on the glider added to the hanger.
These are the results that we obtained from the experiment. For the length of flag S equals 0.1 plus minus 1 times 10 minus 4 meter, means of glider and flag M1 0.19984 plus minus 1 times 10 minus 5 kilogram, and lastly mass of hanger M2 equal to 0.01008 plus minus 1 times 10 minus 5 kilogram.
And for analysis for question 1, plot a graph of weight, force versus acceleration, and this is the graph that we obtained from our data. For question number 2, what does the graph tell us? Okay, from the graph we can show that force are directly proportional to acceleration. This means that the more force they are acting on the weight make the acceleration of the object increase. This depending on the weight that are used. And furthermore, from the graph we can also calculate the centroid of the graph by adding all the y or x values and divide them by the total number of y or x value. And for this graph, we obtain that the central of x is 13.2 and the centroid of y is 0.69. For question number 3, determine the gradient of the graph. So, the gradient of the graph that we obtain is 0.0443. For question number 4 is calculate the uncertainties of the gradient. For the max gradient, we got the 0.05, and for the minimum gradient is 70/440. So if we want to calculate the uncertainty of the gradient, we just need the gradient for max minus by gradient of minimum and divide by half, and that's how we get our uncertainty of the gradient, which is 0.0057. For question number 5, briefly explain the relationship between the gradient from the graph and the total mass. For our knowledge, the mass influence the gradient of the graph. As the more masses are added, the acceleration increase. So the relationship between the total mass and the gradient m are directly proportional.
Next, let's move on to the discussion. First, we need to calculate the percentage difference between the gradient m and mt. What is the percent error in this experimental value? First, we need to find the mt value. Seeing the mt value for all the data is similar, that is the one calculation for percentage difference and percent error. So gradient m we got 0.0443 meter per second square. Okay, to find the percentage difference, we use this formula, which is modulus value 1 minus value 2 over in bracket value 1 plus value 2 over 2 times 100, and the final answer we got 149.97%. To find the percent error, we use the formula modulus value 1 minus value 2 over value 2 times 100, and we got 85.7%. Second, discuss the factors that have contributed to the errors in the experiment. There were several factors that have contributed to the errors in the experiment. First is random error, which may have occurred due to the slight inaccuracy when reading the result. Second is systematic error. We may have applied the wrong pressure to the air blower, resulting in variation between low and high pressure. This could cause friction because the glider might not be fully lifted by the air cushion, leading it to touch the air track surface and create friction. Third, explain how to overcome the factors mentioned in question 2. To overcome the factors mentioned in question 2, we must make sure the reading is read correctly. We can repeat to read the results several times. Furthermore, we need to do the experiment correctly so we can get accurate data.
In conclusion, this experiment illustrates the operation of Newton's second law of motion using a linear air track. According to this experiment, the mass that we add to raise the overall tension is what has an impact on the acceleration. In other words, as more mass is added, the overall rate of acceleration also rises. In addition, to prevent data errors, all information was collected continuously and properly. That's all from us. Thank you very much.